Hello, good morning students. Today we are going to see the topic Introduction to Diffusion Model and its Principles from the course Generative AI and Agentic Systems. Let us start with the recap and with the icebreaking question. How does artificial intelligence generate realistic images? As we know, the jargons, GANs and VAEs are the reasons behind. GANs, which are known as generative adversarial networks, and VAEs are variable automatic encoders. Both are using the transformers to generate the high quality images. So here is the motivation to set up a stable generative learning model through the GANs and VAEs and its transformers. So here the session objective is to understand the diffusion model, how it works, and the two different algorithms known as forward diffusion process and the reverse diffusion process. So, and also the theory and applications of this diffusion model. So here is an image is given of as an example, like cat image, how the training data and image is being diffused. When it is being diffused, the image is being blurred with adding more pixels to that, and finally it becomes a noisy image. And from the noisy image, how we are getting back to the target image. So that is the process between forward diffusion and reverse diffusion. So here the problem statement, let's assume the machine learning engineer or data scientist, they wanted to create a high quality realistic data, and here their pain point is they are lack of unstable training, and they have a very low level of synthetic data or low level of photorealistic data with the diversity. So here is the graph which explains the timeline of 2020 and 2013. 2020 there was, today's AI, where we couldn't achieve the synthetic data and we were able to achieve the photorealistic images, not 100% but very close to that. But when it comes to synthetic data, we would be achieving the photorealistic images in a high level of accuracy. So that is what it is explained in that. So the real data and synthetic data which is completely generated by AI, and the real data which is being fed or trained by the human being. So here what makes the difference? The constraints, the logistics and the privacies. And when it comes to synthetic data, it is completely set up by the statistical modeling and with the various simulation and other techniques. So let us take the empathize process, where we are in need to create a reliable and controllable generation of data which handles the noisy and high level of dimensions, and it has to reproduce the results again and again. So if you look at the diagram, what it is explaining is the high level dimensional data, how it can be perceived. The features has to be selected, then it has to be regularized with the robust algorithms, then there will be incremental or batch level learning. So the transformation of data and the pre-processing. Finally, the dimensional reduction, which makes the results with more accuracy. So let us define the course challenge. How to model complex data distribution, avoid adversarial instability, and how to ensure the training disability. So this is a thing which can be achieved with the diffusion model intuition. So here is an example is given. Initially the cat image, or I think it's a dog image, yes, and how the data is being destructured by adding more noise, which means adding more pixels, and finally the noisy image. So that from that image we call it as Gaussian image. Okay, from the Gaussian image, how the denoising process it happens in reverse, and finally how we are able to create a photorealistic dog image. So here the diffusion principle is in forward process. If you see that data becomes a pure noisy, and it is being controlled with the variant schedule. So here is the original image is given. A woman is wearing the hat, and in the central image is a Gaussian image, is completely noise added. And finally from the Gaussian image, we are reproducing that results with the photosynthetic or realistic image. So here the diffusion process in reverse. Now if you take the X-ray scanner image, and even that image in application level, it is added with the noisy, and finally it produces the diffused image. So from the diffused image, we make the reverse process, we are getting back to the original image. So here the neural network is acting as a denoiser. So again the prototype here, it is image is being corrupted with the noise initially. Then with the progressive denoising process, we are able to achieve the realistic images what we are prompting. So the forward diffusion process and the reverse diffusion process, it's a combination of adding noise and then it is denoising again. So here the applications are matching, time step conditioning and likelihood based training data. Here we have two sets of data. You can see the learning curve. Now here the maximum likelihood of the observing data, it is highlighted with the arrow mark, and in the x-axis the location of the center of the distribution, and in y-axis the likelihood of the observed data. So the new position is much closer to the actual mean of the data, which is the likelihood of the data which is identified. So the applications here, it is used in image and audio generation and medical imaging and scientific simulations. And students are you can take the activity like diffusion model versus GANs. You have to compare it through the group discussion, or you can identify some various use cases how the diffusion model it is used in the image generation. So we have a quick evaluation. So there is an example of comparison is also given between GANs and diffusion. So in future, the latent diffusion model and the video 3D diffusion and multimodal generative AI, so all these things will be having a long scope, and the faster generation we are able to produce the sharper images with a more real-time capacity, with more highly adversarial training with the GAN support. Even the diffusion also will have additional level like stable diffusion, consistent results can be achieved with the text conditioning, etc. So here the summary and reflection, we can use this in arts. The use cases, it is used in art and creative expression, and it is used in advertising and marketing. It is also used in product design and prototyping. So you can say that now why diffusion is stable and where would you use this diffusion in future business. Thank you students. Let us continue in the next class.